Good afternoon.
Good
Hi,
afternoon,
Teresa.
Teresa.
Hi, good
Nice to meet you.
afternoon. Hi,
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 Sanjay.
Pransu. Hi, Pransu. Good afternoon.
Hi, good afternoon. Hi, Surender ji.
Yeah, namaskar. Good afternoon.
I think कल भी हम पैनल पे हैं साथ में
Tomorrow.
परसों
Yeah, day after tomorrow.
परसों
Yeah.
day after tomorrow.
Good afternoon, David ji. How are you?
Good afternoon, sir. I'm fine, thank you. Hope you are doing well too.
Yes. Good afternoon, Teresa.
Good afternoon. How are you?
I'm fine. Yeah.
We'll wait for another minute or two at maximum, and then we will start. We are on a tight timeline, so we would like to make sure we're starting on time. Okay, I think we should start. I hope I'm audible to everyone.
Yes.
Okay,
Yes,
perfect.
yes.
Perfect. Good afternoon, everyone, and welcome to episode 3 of Karo Sambhav Circular Economy Knowledge Series. I'm Shivangi Agarwal, the lead at Project Office at Karo Sambhav, and I'll be your moderator and introducer for today's session. We are picking up from where we left off in episode 2, where we discussed what are the policy considerations that we take into account when we are talking about bringing e-waste plastics into the regulatory fold. Today, we turn towards the implementation of the same. What are the aspects that I need to take into consideration when I'm trying to build a scalable and a robust platform for or dedicated line for recycling of engineered plastics? Because plastics make up over a quarter of every electronic device by weight, yet the recovery remains one of the most underdeveloped parts of the e-waste value chain. While metals anchor much of existing recycling business models, especially with the support from extended producer responsibility policies, plastics are still largely treated as a byproduct rather than an opportunity and a material worth recovering in its own right. And that's what we are here to unpack today. This episode is being held in collaboration with GIZ India as part of Circular Pathways for High Value Plastics in India project, which aims at developing solutions for high value recovery of engineered plastics. Before we begin, I'd also like to thank our sponsors, Apple, Dell Technologies, Canon India, Ericsson, Tejas Networks, Cisco, Boat, and Nothing for enabling this platform and for their continued support of circular economy knowledge building in India. Welcome, everyone. Before we move into today's panel discussion, it's my pleasure to introduce our keynote speaker. Please join me in welcoming Shri Surendra Gothrawal, Scientist E and Additional Director at METI. As METI's Nodal Officer for Circular Economy in the electronics sector, he brings over 12 years of experience in electronic materials, e-waste recycling, and circular economy initiatives, and has contributed to India's Circular Economy Action Plan for the e-waste sector. Thank you, Shri Surendra Gotrawal ji. Please, the floor is yours.
Thank you, Shivangi. So first, good afternoon to all the participants and the speakers, Pranshu, my good friend, and David G, and Teresa. I think we have a good panel today for discussing a very important point. And also, I'm uh, delighted to be part of this very important discussion on this e-waste plastic. And uh, this it is an appreciable job. I see this is mm, done by this GIZ team and this Karo Sambhav. They are doing this web series for last, I think last more than 6 months they are doing this type of web series, and this is the third episode of this web series. This is a very important topic. Today's topic is very interesting. This the title itself gives us the direction that this is not a way that the plastic should be, this only just we have to concentrate on the recycling. We should see the complete circular economy, complete supply chain of this uh, plastic. So this title is also very important, very impressive, closing the loop on e-waste plastic, then building the business cases. So this we are this also a government of India focus on circular economy in 2021. Government of India came up different circular economy action plan in different sector, including e-waste. So in 2021, we also released one action plan on e-waste related activities. So that in that also we have given big focus on this circularity in e-waste plastic. So this is a very important topic, and government is also aligned with different activities. So this I see this. So just I want to give some brief idea or some brief statistics on the e-waste generation. So you see global e-waste monitor report. We have seen this India is the third largest generator of electronic waste, and we have generated more than 4.17 million metric ton in 22. This is a 22 data. It may be more than 5 million metric ton in 2025. So we are the third largest generator. And the other side, we are also the third largest consumer of the secondary raw material. That is one very important point. You see a lot of investment has been made by the government of India last 5 years, we can say, mostly in the last 5 years. Now we have invested a huge amount for the India Semiconductor Mission. Recently, Government of India announced India Semiconductor Mission 2.0, ISM 2.0, with the 1.1 more than 1 lakh crore investment in this area. So huge opportunities there for the this manufacturing sector. So we are also this demand is also growing. So we became the third largest, maybe we can be the second largest consumer of the secondary raw material. So that's why this area is also very much important to see the circularity in e-waste plastic. So you see this, and I also feel that in e-waste plastic management, the shredding is so not this challenge. We have to see other areas like how we can identify the plastic, because we have different type of plastic and they have their each value for different application. So that is also very important identification of the plastic and how we can separate it and how we can restrict different hazardous substances in the plastic and how we can process it safely and how we can bring it in the circularity for remanufacture. So these are the some points I want to give for the discussion also for today's discussion. So how we can identify, how we can segregate, how we can process, how we can bring it to the remanufacturing. So these are the some points we have. I think we should address, and this, yes, the research and development is also very important. We should continue our R&D programs to develop maybe recycling of this e-waste plastic for different application. For example, we have funded one program in SIP Indonesia. So they have developed process technology for converting this e-waste plastic in the 3D filament materials. So that 3D materials that they using for different application. And we are also they also developed this e-waste plastic recycling technology, and they're converting in about 4 different grades of e-waste plastic. They are using for four different application, like this for automotive application, electric and electronic appliances. Also, they are using for these electronic plastic. And some reports I have seen, they are big players that I don't want to name here, but they are moving towards the circular economy. Like one big brand is there. They are using this e-waste plastic or recycled plastic for manufacturing of different like washing machines, this printers. They already started. There are many big brands. They are coming forward and they are adopting the circular economy. So this is also good movement in our country. In global, it is also there. We are adopting good best practices in our country. And you see, EPR is also their extended producer responsibility. in rule itself it is there. So I think your manufacturer is also making themselves as a responsible entity, and they are also adopting this circularity. So different, I think a lot of push is also there from government side, and awareness is also being created through GIZ and this Karo Sambhav, many other agencies also working in this, like Panasonic is there, Harikumar program they are doing, Samsung is also actively involved in this such type of activity. So they are bringing awareness also. So this is also a big movement towards the circularity. And the government of in India also initiated Mission Life. So in Mission Life, this e-waste plastic also considered a big movement. You may be remembering the last 1 year we are celebrating this mission. Maybe I think more than 1 year. But this we are doing a lot of activity for such this awareness activities. We are doing capacity building program. We are doing under Mission Life. So many activities we have initiated. And NITI Aayog also brought a report in 21 on circularity in this sector. And technology wise, actually we are the electronics and IT ministry. So our main focus is the development or this R&D technology, research and development technology, also bring awareness and capacity building program we are involved. And we are also doing some industry, like we are also planning to have some maybe some incentive scheme to promote circularity in the manufacturing, that also we are doing. So we are being electronics and IT, we are in this sector. So we have our autonomous body, Center for Materials for Electronics Technology. So we have developed different process technology for recycling of printed circuit board and the lithium-ion battery and the solar panel. Although this is for e-waste plastic discussion, so I'm not going in deep. So CPET is one of the organizations we have created such technology. And I want to highlight some of the things like ROHS compliance. So that is also maybe important for this area. So we have set up one ROHS lab in our CMET lab at Hyderabad. So that is also a reference lab, CPCB's reference lab that also can be utilized for different testing parameters. And I see the in e-waste, I think we have more than 25% of the weight of this plastic. So that is very, I think maybe you can say quantity wise, we have good amount of plastic they are generating. So we have to see how we can better utilize or we can go for remanufacturing. And recently we have started initiated one program on e-waste recycling cluster. We are going to set up 30 recycling cluster across the country. So in that cluster, we have also considered this e-waste, this plastic cluster in our this recycling cluster along with the PCB recycling. So CPET technology we are using, and we are going to set up a different cluster across the country. So we initially it's a pilot project actually. So we are considering 30 plastic recycling cluster. One will be in one state. So this is also one big program we have started in our country. And you can see this NCMM is also a big movement by the government of India, National Critical Mineral Mission. So in that also we are considering this along with this TCS metal recovery and the critical mineral recovery. We are also giving focus on this plastic recovery also. And I see there are different type of plastic like ABS is there, PP is there, high impact, this HIPS and polycarbonate, different blend and different type of plastic is there, and they have different type of applications. So I see this different type of business model also we can develop with the what type of grade plastic we are converting to the recycling. So different market is should be there. So I see I think there's the big gap is the skilling, how we are identifying, how we are recycling, what are the process we are using, and what is the demand for that particular grade of plastic. That also should be considered. And I see their standards also. I think we have to look. I'm in the one of the committee in the BIS. There we are having bringing some standards on the environmental aspects for e-waste related area. So I think we can have, or we can maybe in your report also with the discussion. After webinar, you can submit a report to us. You can suggest some standards for secondary raw material. That what are the secondary raw material? Maybe based on the international standards, how this recycling standards. Therefore, secondary raw material we can be used for further remanufacturing, or what is the demand for the this further product manufacturing? What type of standard e-waste plastic or plastic we require for the remanufacturing? That those type of standards also needed. We have to start thinking. And I have seen some of the global best practices like Japan is also focused on eco design and traceability. They're also bringing digital product passport, and the European countries also doing good job in digital product passport. They are trying to trace the complete material, like we can say from the manufacturing to till end of the recycling of the material. Then after the recycling, where this material is going for further, maybe it is used for remanufacturing or it is going for other purpose. So they have complete traceability. Such type of mechanism also we can have in our country. So we already started working on this DPP, this product passport, with the help of GIZ team. So there are some other countries, they are doing good job in tracing of this secondary raw material. And I can see some of the business opportunities also there for such type of this recovery. So different type of plastic can be used for different applications. So you see there's a lot of business opportunities there. And Ministry of, I think Ministry of MSME, they also came up with one big, I think good scheme is already there. They are funding good amount, I think 70% subsidies for cluster making, but any type of cluster can be set up in a one, maybe in a with the people of 10 people minimum, so they can bring some cluster in the country. They I think they are providing 70% of capital subsidy. So e-waste plastic may be considered. So this is the information I want to give. If anybody is interested to have one cluster, e-waste plastic recycling cluster, they can submit a proposal to Ministry of MSME. They have scheme and different scheme. I see this. Some of the state governments also bringing some incentive scheme. They are providing land also. I seen recently government of Haryana, they announced one big scheme on e-waste. So they are including plastic also. They are allocating some location of land for specific this waste treatment plant. So some incentive scheme or the other type of infrastructure facilities also being created by state governments. So now we can see we are trying to create an ecosystem in our country. We hope maybe next 5 year, 10 year, we will be have good mechanism for this towards circular economy in this or plastic related area. So this is from my all from my side. So I want to thank GIJ team and the Pranshu Karo Sambhav for having such type of events so that we can share or we can also learn from you. What are the whatever suggestion we are getting from you, only that we are implementing in our the policies. We are building our policies. So thanks for inviting me. Thank you.
Thank you so much, Surendraji, for joining us today and for providing a perspective, because it's very heartening to know the amount of effort the government is also putting in to build that ecosystem. And as more and more of us are identifying what other fractions we can focus on, it's important, as you said, to develop that ecosystem and not only look at just the downstream of recycling, but also look at upstream and what interventions we can take upstream, both from a design for recyclability perspective as well as from a digital passport, product passport perspective. Thank you so much, Surendraji. Moving on to our panel discussion for today, allow me to introduce our 4 panelists that are joining us. We have with us Mr. Sukrit Bharti, founder and managing director of Virtuoso Optoelectronics Limited, Nasik. He has extensive experience in electrical and electronics manufacturing, and he brings his expertise in business strategy and operations. He holds an MSc in engineering technology from BITS Pilani and has received executive leadership program training at Stanford and Harvard Business School. Our second panelist for the day is Mr. Sanjay David, sustainability representative and lead of market development at Covestro India. With over 3 decades of experience in polymers industry, he brings deep expertise in polymers, additives, sustainability, and business development. He holds a postgraduate degree in polymer sciences from Central Institute of Plastics Engineering and Technology, CPET. Our third panelist is Pranshu Singhal, our founder, who is here to talk about the different aspects which need to be considered and which affect the operationality and scalability of a dedicated recycling line for engineering plastics. And our fourth panelist is Theresa Ehner, research associate at Fraunhofer IZM Berlin. Her work focuses on sustainability and circular economy solutions for the electronics sector, including the Horizon Europe funded INCREASE project on increasing the use of recycled plastics in electrical and electronic equipment. She's also a co-author of Developing Recyclable Electronics Devices, a playbook for design for and from recycling, and hosts the INCREASE Crash Course webinar series on e-waste plastics recycling. With that, let's dive in. As we have covered in our previous webinars, and as Mr. Surendraji also highlighted, we have talked about how important it is to look at e-waste recycling or e-waste plastics recycling as an ecosystem work and not just a technology barrier that we need to cross, right? And One of the biggest aspects in this has been the matchmaking that happens between what the recycler produces and what the buyer of that recycled content needs. And I think one of the best examples for this, for me, has been Sukrit, the work that you have done at your plant, right? Virtuoso already runs its own injection molding at scale. And as part of that, I want to ask Sukrit, what do you currently do with the plastic waste that your own production generates? And how much of it goes back into your own new products?
Firstly, thank you, Shwangi, and uh, thank you for having me here. It's good to know all of you here. It's good to meet the panel. I think I would break recycling even before it goes into the market into two phases at the factory level itself. So one is the design waste that gets generated in any plastic manufacturing, which is whether you have your runners, whether you have your extra material that goes into any production, which is the first step of recycling. Of course, a lot of manufacturers do recycle this, but then there are cases where you have the finished surfaces where you can't use too much of recycled material, or you have areas where you can't recycle this material, but you need to find ways and secondary parts where you can probably recycle this. So this, I believe, should be recycled to 95, 98%, or even 100% of the design waste that gets generated. In plastic, I think it's relatively easily doable. If there are industries which are not able to use it, I think we should find matching industries where this can be done. So this is the first part where I think generation of waste probably is not an efficient manufacturing system. The second part is the process waste where you have rejections online, you have material which goes to waste for some reason, there's breakage of material. All of this material, how much of it can be recycled and what is the situation is the second part. Of course, this can be 1%, 2%, 3% of your overall production, but ultimately everything adds up. So in this case also, we at our company try to use it within the same product in some internal parts, the cross product. So we do basic regrinding and we try to use it. I mean, to an extension of plastic, even in polymers, we have our own extruding. We recycle EPS, we extrude and we make pellets, PP pellets, and then try to use that also in some products where it is an internal part. So I think any process related rejection also, if you work and you pay a little attention, you can have invest a little bit and you can create your own circular reusability. The third part is, of course, when the product goes into the market and then the entire complication of identification and recollection. And I think the other panelists probably will have better insights on that. But that is what we are currently doing. And we are doing this not just in plastic, but we are also doing this for metal. For example, metal scrap from AC heat exchanger we are using for lighting. Lighting part production, which are made of aluminum, or so anything where we can mix and match. We are of course trying to do that so that we reduce the amount of waste that goes out of the factory.
That's very interesting, Sukrit. But I think if I recall in our conversations, you had also shared there's a certain specificity even for the reject waste or design waste as to the age of the plastic or what specific product the plastic is coming from. And as much as possible, if I recall correctly, you put it back in and either try to use it as soon as possible, or you put the plastic rejects or outputs back into the same kind of product.
So in our experience, we have faced problems when with plastic ages. So after molding of a certain part, and if it ages over time, over a few months, or if it's exposed to UV, or if it's exposed to sunlight, then recycling it becomes that much more difficult. The properties change of plastic over time. Of course, like I mentioned, I think in our call also, but we don't have the exact expertise, or we've not gone into the molecular or structural changes that actually happen in the material. But we've not been able to effectively use it again as fresh material. If we do it within a few days or online, then I think the process of doing it is much easier and much smoother. So that has played an important part. Also, there are certain plastic grades that are more difficult, the talc-filled material, the sand-filled materials. These materials are more difficult to reuse. Do it in case in a few days or waste in the online system, or the percentage that you can reuse as a part of the recycling process is plastic. We're also so if you have simpler plastics, I mean the base plastics, I think you can even use 50%, 60%, 70% of recycled content in your molding applications, or
what specific product
any
the
usage
plastic is
applications,
coming
or
from,
extrusion
and as much as
application
possible,
for that matter.
if I recall correctly,
But
you put it back in.
the same is not
either
true with materials which are already recycled or engineered plastics, where this becomes more and more difficult. That also draws me to the point where to discuss molding engineered plastics that are coming into the system are of course adding value in terms of enhancing plastic properties, in terms of probably increasing. We don't have the exact expertise, or also we've not gone the challenge that whether or waste and recycle them smoother once they go into the market. That has played an important part.
That is absolutely
Also, there
true,
are
and I
certain
think
plastic
it
grades
also
that are more
becomes very
difficult.
pertinent
The
when we
talc-filled
talk about how
material, the
specific the
sand-filled materials.
requirements
These materials are more
from a
difficult
manufacturing point of view
to
can be, because
reuse.
there is a
So
certain
in case in a few
standard to
days
be
or
maintained for the
waste
end
in
product.
online, or the
And that is where I
percentage
think
that
your
you can
point on
reuse
using
as
it
a
in
part of the
secondary parts also
recycling
comes in,
process is
because
much
while
more.
the
So if
finished
you have simpler
parts may
plastics,
not be
I
able
mean
to
the
use the
base
recycled
plastics,
content,
I think you
maybe the
can
secondary
even
parts
use
can
50%,
use.
60%, 70% of recycled
I have a
content
question
in
as to
your
because we have
molding
heard how
applications,
specific
or
the requirements from a manufacturing point of view can
any
be.
usage
We
applications
would like
or
to know
extrusion
how
applications.
tight are those tolerances, and how much variation can be allowed from, say, one batch to another. I do have a follow-up question, but using it first on this part. How tight are the tolerances from a manufacturing point of view, parts in terms of the quality and the specifics
I
of
think you
maybe
can
the secondary
even
parts
use
can
50%,
use.
60%, 70% of recycled
I have a question
in
as to
your
because we have
molding
heard how.
Also to the audience, so coming straight away to your question, it all depends on what you want to achieve at the end, right? Most of us, like when we are talking today, we see a lot of graphical representations of closing the loop, and typically, you see that it's one circle. You have different stakeholders around it, and then one circle you go around it. But audience, Pranshu, I see you smiling because we've already experienced this when we try to really dirty our hands with the waste. in each of these stakeholders,
you have different
you'll
stakeholders
find
around
concentric
it.
Because
circles
when
itself.
we talk about
So
from a
many of
specific
them,
manufacturing point of
and
view,
it's so
probably
use
as a
the
plastic, we
capital
would like to know
exposure
as
to
much
it.
as tight are those tolerances,
it's extremely
and how much
important
variation can be
to
allowed from
identify
say
the
one batch to
feedstock
another.
Very
Manufacturing
simple
point
to
of view,
simplify.
closing the loop,
straight away
right?
to your
And
right.
to repurpose a particular material.
Graphical
It starts
representations
from
of
there. And when
closing the
especially
loop.
when we talk about
Yes,
e-waste
sir.
itself, what you want to Surendraji said,
The
just
second
mentioned
part.
that almost
Uh,
25% by weight is plastics in
talk about
e-waste.
how
material, these
specific the
packaging
And in
requirements
this
these materials are
25%,
more
from a
difficult
manufacturing
you
point
will
of view
find
can be,
to
because there
zillions
is
reuse
secondary
of
parts which
recycle,
is
not just
consumed,
plastic.
secondary
You
parts
use
can be
50%,
used.
60%
Even for
recycled
the
material
Sanjay,
waste
I have a
on
question
this in
as
your
to you, because we have
engineering
heard how
applications
specific the
or
requirements from a
are we
manufacturing
going
point of
to
view
close
can
any
be
use
as a
of
plastic. We
application
would like
for
to know
exposure
as
to
much as
each
tight are those
of these
tolerances,
zillion
and how much variation can be
I'm just
allowed from
not
say one
talking
batch to
about
another.
the
I do
plastic
have a follow-up
content
question, but
use
using
as
the
a
first
part
on
of
this
the
part, how
recycling, not
tight
just the
are the
plastic.
tolerances
Earlier
from a
also we used to have
manufacturing
simpler
parts
plastics,
in terms of the
the waste plastic.
quality and the specifics
I
of
think
the
in
secondary
you
parts can
use
be
50%,
improved.
60%,
For the
70%
Sanjay,
of
I have a
recycling
question
content
plastics
in
as to
your
because we've
loading
heard
package.
Also to
we said,
the
okay, we
audience,
might sit and talk and discuss,
coming
make a lot of
straight away to your
plans
question,
on paper and whiteboard.
it all
But
depends on
unless
what
we
you
put
want
our
to
hands into
achieve
it,
at
we're
the
not
end,
going to
right?
reach anywhere. So we
Most of
took
us, like
a
when
few
we are
of
talking
the
today,
take cover,
we
we
see
cover
a lot of
laptop covers from Pranshu, and then
graphical
we tried to see.
representations of
There we saw few were painted,
closing the loop,
few were had
and
adhesives, few had inserts. So when I talk about the
typically,
zillion
you see that
combination, it's all
circle.
there. And how are we going
You
to get
have
this?
different stakeholders
So,
around it.
because
One
we've heard
circle
how
to go
extremely
around to
important,
but
how
audience,
get this
Pranshu,
right.
I see you
coming
smiling
stock,
because we've already
for
experienced this when
repurposing.
we try to
And there,
really dirty
in
our
terms
hands
of
with
e-waste, is a big
variation
picture.
can be
I'm just
allowed from say one
talking
batch to
about
another.
the
I
plastic
do have a follow-up
give you
question,
an
but
use
using
idea
the
as a
first
part
on
of
this
the
part,
but
how
recycling
tight are the
process.
tolerances
challenging it is.
that
Combination at COVID
it's
also
all
there. We
I
are
from a
think if you have
manufacturing
simpler
parts
plastics,
in terms of the
the waste
quality.
plastic.
So what for the last 10 years we've been offering PCR grades, and sad to say that we have still not found a source from e-waste to be our feedstock. It's all from other industries that we get the feedstock. Because there is a relative amount of consistency, there is a relative amount of certainty, and there is the recyclability becomes a little more easier. So it's extremely just to close it in one sentence, extremely important for a company like us, which wants to offer PCR grades to the market and to the industry, to get a very consistent and reliable source of feedstock for us. And here I just touched upon one aspect of the consistency and the complexity of the material. When you look at when you have to recycle or repurpose in a responsible way, there are several other aspects that would come into picture. The ethics of recycling. We know that the recycling industry, at least in India, is a very labor intensive, and we know the kind of labor that is employed in this industry, right? And for us, it is extremely important to see how ethical, whether child labor is involved. Are we doing it ethically? Are we further deteriorating the environment by looking at these sources of feedstock? The second part is what Surendraji mentioned about ROHs. How are we meeting the standards of when you look at all of these, the source is the crux. And there we definitely have a challenge in e-waste.
Absolutely, Sanjay. And I imagine for you as well, while as a manufacturer of those plastic raw materials, you have to look at your feedstock. You also have to keep into consideration the specifications that your own customers have set up, right? And you need to make sure that quality does not decline in any way or manner, because then that material doesn't get accepted further on. And on top of that, of course, there's also the point that Sukrit also brought up regarding how many cycles can plastics actually go through in recycling, because after a point in time that the properties also start degrading, and that starts affecting the overall composition of the compound that we have created. There are a couple of questions that are coming out of this, Sanjay. One of the questions is actually on collection aspect of things, and the other is on design. So I'll actually go to Pranshu first. Pranshu, considering how complex the collection for products and sorting after dismantling is, how important it is to make sure that you're sorting it to a cleaner and cleaner fraction so that it can go into a proper line and get to a particular quality. What kind of considerations have you been evaluating in figuring out the collection channels for this?
Well, there are no considerations because people give you whatever they give you. I mean, how do I stop someone from giving me a mouse and only giving me a AC and saying no to a keyboard while saying yes to, let's say, a speaker? So the reality is, when we talk of recycling, we can't be selective. I mean, selective is breaking the trust of a consumer if you are being selective. And historically, why e-waste has been mismanaged is because there have been very selective picking of certain varieties of materials. One would like to go after copper, someone would like to go only after certain types of boards while leaving all the others. So, and in all my detailed discussions with, for example, Sukrit, where we have been debating how to solve this problem, the biggest challenge has been how do I give him a consistent supply, because I don't know what am I going to get. So the only way to know what are you going to get is either you tie up with the retailers and then you power large scale take back programs of similar variety of products. But again, that becomes very challenging beyond a time. But this is a big issue. So again, do I have an answer? The answer is no. One will have to crack the code of multiple types of plastics, at least in the same basket. So ABS could have multiple varieties, like or zillions of varieties, like Sanjay was talking. So how do you now crack all those varieties in the same go and work with Sukrit in some form that he does magic so that it could go back to a product? So again, it requires a lot of magic to happen. And honestly, all of us are struggling in our own spaces to figure out how do we make this magic work. I don't, of all the people that we have on the panel, I can't say, that anyone is there who is not wanting to work on it. All of us want to work on it, but the hands are completely bound. You don't know what to do to make it happen. I mean, even if I were to just collect mouse or let's say just keyboards, I mean, there are millions of varieties of keyboards from the same brand. Forget, multiple varieties of brands. Everyone uses a composition that they like, what works for them. So, how do you create those things? Eventually, I think where I am, and again, I've been talking to a lot of now technology providers at a global level, whether it is from Europe or, people who can help in putting up a whole line for doing this. I think where everyone is that circularity is probably an impossible task here. Some downgrading would happen and one will have to look at applications. So one has to start with application and then look at, okay, what varieties of waste can actually go into that application. That may be a better route. But the problem again with setting up very large scale plants is how do you guarantee feed? How do you give a commitment to an organization? Let's say if an organization like Virtuoso commits to using X amount of plastic, can we guarantee that we can give this feedback, this amount of material consistently with consistent specs, because your input is so variable. So again, I'm only putting up the challenges. I believe we will find some solution. Teresa has done a lot of work, so let's hear from her.
Thank you, Pranshu, for leading on to my next question, because that was going to be my question, Teresa. Considering how often we have heard how complex plastics are purely from a product design perspective, what has been your experience in seeing how much of this complexity and the the different types of additives that we add, how much is that a design problem? And what has prompted your work and Increase's work to move upstream into design in the first place?
Mm-hmm. Yeah, thank you very much for your question. Also, thanks a lot for the invitation. I'm really happy to be a participant of this and hearing all the stories. Now, I was already noting down many things that are so interesting that would, I think, deserve also follow-up conversations. But getting back to your question, I think what also now you mentioned, Pranshu, was that looking from basically starting with the perspective of which product do we want to design, so what material do we need, and then only looking into which stream can actually source we source it from. This was also the approach that we took in this EU project called Increase that you were already referring to. So we had 5 challenging applications where we already knew, okay, which type of material are we looking for? And then we identified all the specifications for that. And only then we looked into, okay, which waste streams from the e-waste specifically can we source it from? So therefore, we also started clustering different product categories, as for example, e-waste toys and also printers and copiers, where we were looking for different specific polymer types. And I can say that in the project itself, thanks to the fact that we had all the supply chain present in the project itself, we managed to do so for all the different products. So that was successful. But of course, it was a research project and it is not fully reflecting what is happening in the industry currently. But we hope that with this, we can also kind of start guiding also regulation towards supporting an ecosystem where this is actually feasible. But yeah, in terms of the additives, so to touch upon your question, I think that's also like one of the main challenges that we realized, or that is present also in the European context, that the more additives we add to the polymers, the more difficult, of course, it becomes, because in Europe, at least, we use a lot of the sink float processes to separate different polymers. So then if you add a lot of fillers and additives, the density of the polymer changes, and then we lose a lot of those polymers. So these are also definitely challenges that we're facing in the European context. However, the difference, I think, the major difference is that in Europe we have such high labor costs that we cannot do a lot of disassembly and dismantling. So therefore, there's also a lot of research and development ongoing in the sphere of robotic and automated disassembly in order to also harvest more parts and more materials. But of course, the more expensive a material is, the more lucrative it would be. So as always, the recycling sector is mainly driven by the metals, I think, and that might also be a bottleneck for this approach.
That is very true. I also wonder Increase's recyclability assessment tools that scores how design variety creates a certain amount of inconsistency. Is there any risks that you have seen that are popping up again and again, and any that seem solvable?
Yeah, I was reflecting on this question up front already, and I think it's a very interesting one, because for this recyclability assessment tool that you're referring to, which we developed together with Philips and Pesi in the Increase project, we really focused on the European recycling context. So basically, this tool helps designers to design products in a way that they can be recycled at end of life. But the recycling system that this tool is basically based on is really referring to the European context, where very few disassembly and dismantling steps are happening and not a lot of harvesting of separate valuable parts. So therefore, I think definitely a lot of the challenges or blockers that we indicate in this tool as being a blocking factor for recycling in the end can definitely be solved if the recycling system, for example, would change. So, for example, I was reflecting a little bit on the decisions that are behind this tool. For example, if you have click fingers or any connections of parts that are basically breaking up if you use a little bit of force, we indicate in this tool that this is positive for the recycling sector. But for example, for screws, it is marked as moderately recyclable. And maybe also question to this round for the Indian context, where, as far as I know, a lot of disassembly and dismantling steps are happening. In this case, the screw might also be a good option, because you may assume that it would be unscrewed in the recycling context. But maybe this question is also dedicated to any of you in this round who has more insights on that.
On the screw side, I can add. Sorry, Sukrit.
No. So please continue.
Yeah. So on the screw side, it really depends on how rusted. In most cases, yes, they will be taken out. But on an average, what I see in our waste when dismantling is happening, that in plastics, at least 20 to 30% of the screws remain. They are either somewhere hidden or they are somewhere deep. So people end up breaking, because again, the time is of value. How fast can you dismantle, rather than are you able to dismantle each and every tiniest fraction? So they do remain entangled at times. Over to you, Sukrit.
Just to continue on the entire discussion which we are having, I think there is if you look at the entire problem in one set, I think it's way too complex to solve. I think, like Mr. Sanjay mentioned, or I mean, the entire experience of, I think, doing it in one puzzle is difficult. But I think if we can break it into blocks, or we can find ways that, let's say, if we manufacture X product and we know that after 5 years we are going to get our product back, then we know that what went into it and what can be recycled. Maybe if it is 10 years old, it is already too late and it is probably not salvageable. But if we can classify material into buckets, probably more doable in a European scenario than in Indian scenario. But if, let's say, you have an end of life at 5 years, and if you are recycling within 5 years, you can derive X value out of the product. That is also if the product goes back to the same person. So, or the person who made it, because they know what they put into it. I think if you can create smaller loops, I think the ecosystem is more viable and doable. Because of course, if the cost goes up, then everybody likes the concept of being environmentally conscious, but nobody likes the concept of paying more for it. So I think we have to create these smaller loops. If we can create them, I think this is a more doable mission. Instead of trying to solve it at a macro level, which I believe is much more complex. So, I mean, that was my input.
No, absolutely, Sukrit. I think I do wonder, one question I do have. You earlier on sort of created a small distinction between the outer finished parts of plastics versus the secondary use parts. Is there any further scope to, for example, only consider incorporating recycled plastics in parts which are not getting in contact with consumers, and therefore the finish and touch and feel of them are not as important a consideration?
I mean, so that goes back to the grade, because if the grade is not correct, the machine cannot mold it, the part cannot be accurate, and the fit and finish is not there. So that is one. But I think what I'm trying to say more is, let's say we don't solve the full problem. What we can at least do is, let's say, we identify where all waste is getting generated. One is at the consumer end, one is at the supply chain level, one is at different factories. So if we can at least say that if my factory generates, let's say, 10 kilos of waste every day, and somebody can consume that 10 kilos of waste because we know what is getting generated, at least that be close. So that is a smaller loop, more understandable, more predictable, can be addressed. Then you go higher, where you say that products made by X factory come back to the same factory within X number of years. We can still understand what we put in, and we can still segregate it, probably use it. Because I think, like I was discussing with Pranshu I think last year or something, that unless we sort of get a refurbish element to a product, only recycling, the value creation is not probably enough to sustain that cycle. So if the product goes back to the same person and there is a certain element of refurbishment, there is a certain element of recycling, then it makes the entire system more interesting and valuable. Executing is a bigger challenge, because in India we tend to, the first person uses, then probably a second person and the third person, and then it ultimately ends up in a condition that's so bad that probably not easy to salvage. So probably in European countries or American countries where you have people recycling at a fixed period of time, and there is a traceability of which factory that material came from, probably we can create a case of recycling it or reusing it or refurbishing it within the same structure or concept. Is more doable, especially in case of plastics, maybe in case of even electronics and other components, because I know exactly what I put into my product.
That's very, very pertinent. So, Pranchu, I have a question for you then. How likely is it for us to build something like this, have dedicated channels? Because of course that doesn't solve the concern regarding the heterogeneous nature of just general consumer collection. But would a mechanism like this be possible to execute at a larger scale? Very targeted collection and then putting it back into the same factory.
I believe so. So it all depends on the unit economics of what is being created. So if the business math works, then one can look at a very targeted collection. You pay higher prices for that type of material more than the market rate. So I think those things are doable. What we are trying to do in this program is, can we set up a line, and then figure out what are the varieties of materials that have to be collected at large scale. So let's see how it goes. I think I see a lot of merit in what Theresa has been doing. And some of those things could be replicated in terms of, because when I look at the work which was done, it had a lot more implications from an emerging market point of view, because the labor is cheap. So a lot of things that were recommended could be very applicable in our context. So I think what we are arriving at is, and not just in this particular materials case, but in many other cases, is that a lot of solutions, the moment we talk of either critical raw materials or materials which are deep inside, or require a better level of dismantling, the traditional method of Europe doesn't work, because in that you crush everything. So fundamentally, approach of emerging markets combined with some European technology, which again needs to be evolved. The thing is, there is very little maturity on a lot of these solutions. A lot of need is there. A lot of people want to do it. But how do you do it at a competitive cost, like Sukrit mentioned? That remains the key. Because without it, it can only be government's mandate that you have to have a recycled content of X percentage, and then it will, because there is no other way out. Which is what I think most of the organizations at a global level are reaching, that a clear government mandate to use recycled content probably becomes a way to create the market rather than doing it the other way around. So markets are on their own not solving the problem.
I'd like to go back to the small circular loops point that Sukrit had brought up. Sanjay, my question is to you. If you've seen any examples of these smaller loops that were created for a particular material type that was successful in taking maybe post-consumer or reject plastic waste and reintegrate it.
Yeah, so we are working on a project now in this within this initiative with Karo Sambhav and GIZ, where we are looking at very targeted waste streams. For example, what we're looking now is a huge end of life of energy meters. And this is going to be like the government had a mandate of around 250 million energy meters being replaced. So that means 250 million energy meters are going to reach end of life. And there is a good scope for us to look at this one particular stream and then try and build a whole circular loop around it, because as I mentioned already, that we are very deeply involved in the polycarbonate business, and so we can maybe even draw a program for meter to meter closing the loop kind of activity. But having said that, we've already demonstrated this in Europe, where we have a project which we have said it will, and which is also done from spearheaded from China. That is for end-of-life vehicles, where the vehicle, the plastics, the high-value plastics from the vehicles are brought back into the vehicle itself. So this has been demonstrated, but like Pranshu mentioned, many of the technologies, at least, and the motivation for investment and to see this entire picture, evolve, that's becoming a little bit of a challenge. Few people see it, other stakeholders don't. And then, so we are, at least, my experience in India is that we are still trying to figure this entire value chain of how to repurpose. It's all in bits and pieces. We are trying to see how to bring it together. So there is tremendous scope to close loops for a given stream of waste. But when you look at it, like Suprit mentioned, when you look at it from the macro level, it still looks like a problem. There are only very few technologies which have not been scaled yet globally in terms of chemolysis or any of those kind of processes. Those are ideas and technologies which can solve this in a macro level, but that needs to be scaled up many, many times for us to see some kind of a result. So to answer your question, definitely yes, if all the stakeholders can come together.
Of course. Thank you, Sanjay, for that perspective, because I believe even with the pilot for end-of-life vehicles, it is, I think, a specific part of the vehicle, the lamps, right?
Exactly.
The headlight lamps.
Exactly.
Because the need is for clear plastic, so specifically the headlight lamps are being used to then get recycled and put back. I do have a question, and not to you, Sanjay, sorry, to Teresa. How do you see the work or the inputs from recyclability assessment tools sort of affecting what kind of role design plays in the future, or what is designed in the future?
Yeah, thank you for that question. And I think it's a very important one to address because, of course, we can try to recycle as much as possible. But if we design products that are really consisting of trillions of different materials that cannot be recycled, then also the best recycler cannot do anything. So basically, we should start at the design of products in order to then also, facilitate the recycling of it, because it's basically the problem that is being created at the design stage. So therefore we were also quite intensely focusing on the eco-design or design for recyclability in this increase project, and we came up with some design guidelines that I'm also happy to then share in the chat, and the tool that you have mentioned. And particularly we produced also this tool because what we usually see is that the design world doesn't really talk to the recycling world. So there is quite a knowledge gap there. And of course, designers are trained to design products and not trained to design recyclable products in like the first primary education that they get for as a product designer. So therefore there is really a gap that we see between these, what we even call two worlds, the production world and then the recycling world. But we need to find a way to match them. And this tool really bridges this gap because by using this tool, the product designers don't have to dive into all of the nitty-gritties of the recycling system, which we are just discussing is even a very complex one and not so easy to understand. And therefore, this tool really aims to help the designers to already from the start of a concept, it can even be only a concept that they're evaluating, to see, okay, what would be the major parts that are affecting the recycling stage. And then from there onwards, ideally they redesign or maybe they change a few things here and there in order to have to really use those low-hanging fruits to be changed. Maybe not to have the perfect design, because of course there's also other stakeholders involved in the product design, such as marketing and so on, which might tell you like, no, this is really a no-go for, we cannot market a toothbrush which is black, for example. But it is really important to already from the start of a product design look into these questions, because then you really still have the possibility to change your design. And once a design is finished, of course, we know that the manufacturing industry is not happy to change even from one polymer to another once the design is already there. So I think it is really crucial to start at a very early stage. And this is what we also tried to do with this recyclability assessment tool.
Thank you, Teresa. I think what the conversation today and the previous conversations that we've been having makes it very clear, I hope, is how we can't treat plastics as a monolith material, because both from the perspective of the kind of collection systems that exist, from the material properties themselves to the specifications or the tight tolerances that manufacturers have, we need to look at it at a much smaller or a more broken down scale of polymer by polymer or grade by grade, because I don't think there's ever going to be one solution fits all, but that's especially true in the case of plastics, where we do need to set up some sort of a balancing act between how we can tackle the waste we get today, whether it is making peace with knowing that, okay, maybe it doesn't go back into the same grade of product, and maybe there is some level of downcycling, but if it's not as severe a downcycling as was happening in the current system, and it is able to tackle some of the socioeconomic problems that exist in current recycling chains, while simultaneously also working on, for example, upstream interventions and interventions at a material level or a very specific product level. There has to be multiple interventions that we are running parallel. I would like to thank all the panelists for your time today. I think e-waste has always been a very complex product, which makes it very, very exciting to see what we can do with it and how we can figure the solution out, because there's not a single solution, whether it's in the same country or it's globally, right? So before we close, I would like to thank all our panelists for giving their time, our keynote speaker, Surendraji, for giving his time today. I'd like to thank our sponsors once again, Apple, Dell Technologies, Canon India, Cisco, Nothing, Board, and Tejas Networks. And to our collaboration partner, GIZ India, for making this platform possible.